And then what I'd like us to do is to, as we're working on where we left off, we will move into programs that we're going to use. Just a bit of housekeeping though. First, I said we'd work backwards from Thursday. So Thursday, we have our first exam. On Canvas, there is a practice exam and a practice exam key. There should be a key. I'll tell you a little bit about that in a little bit, right? Don't stress. That's all that you need to know right now. Normally our homeworks are due on Sundays, but I'd like to make sure you get as much practice in as possible. And so I'm going to ask you to turn your first homework sets in by Wednesday, okay? So we'll jump on Canvas and we'll look at our schedule. We'll make sure that you know where you are. So to that end, I want to make sure that we're confident about the concepts and skills that you will work on or exhibit on the exam, and that you're able to practice with those by way of the homework that's assigned, which means that we want to make sure you're comfortable with the following two learning programs, Tarski's World and Fitch, and that also you are comfortable working with the email program, it's called Submit, that you use to send your homework in to the GradeGrinder. I will also make sure on Canvas there are written instructions for using Submit, that those are posted under that top module on the page that's linked to that top module. It's something like LPL downloads, whatever, I don't remember the name offhand. And then I already have, I think at least one Submit tutorial, but there will effectively be another one because I'm recording, again, with your permission, this class. So it should be the case if I've set up the computer correctly. And hold on. Same thing that happened last time. I forgot to turn off the internet, so it's dinging away. But anyway, so what was I saying? Oh yeah, so with your permission, I'm recording this, so I'll post it up on Canvas if you want to look at it. All right, so under Chapter 2, we were working on the following concepts. On Tuesday, we were talking about what an argument is. So we defined it. We talked about an argument as consisting of sentences, well, but not just any old sentence, a sentence that has a truth value. That is a sentence that is true or false, right? So very often the language that's used to talk about truth-bearing sentences is statement and proposition. For our purposes, we're going to talk about sentence, statement, proposition, claim as being interchangeable in terms of those utterances that are either true or false. We talked about those sentences in an argument that serve as support, evidence, reasons to believe another sentence, the premises. So every argument has at least one premise, could be multiple premises. And then that which is inferred from the premises, namely the conclusion. So here are a couple of arrows and some more language that we've been using just to summarize. The premises imply the conclusion. The conclusion is inferred from the premises. Right? So all this language should sound familiar. We're going to use it. It's just part of the sort of our working apparatus, our working terminological apparatus. Okay. Then we we began working with, although didn't really get into technical detail on the following. We wanted to talk about a valid argument, and I'm abbreviating argument with arg. A valid argument, which is which we can also talk about in terms of logical consequence. We also want to talk about the concept of an analytic consequence. And then if we have time today, great. If not, Tuesday, we'll talk about a sound argument. Okay, Sophia, what are you thinking?
Is the test next week a reflection of like these definitions, or?
Right. So, two things. One is you will know exactly what's on the test because I'll tell you in terms of concepts and skills, but also because the practice exam has the same format, the same level of difficulty, the same number of exercises. So the idea is that you know what you're going to need to practice so that you can perform, as it were, on the exam. Now, what I won't do on the exam is ask you to define, right? There's no multiple choice or fill in the blank or that sort of thing. Instead, when I, in a prompt or in a given exercise, use the terminology, you'll know what it means. You'll know how to use it, okay? All right, so let's make some headway then on these concepts by way of our programs. Okay, so you should, okay, so here's my drive. I've named it, and when I click on it, yes, it's a little bit of a mess. I gotta clean up. But you'll notice that, for example, even though it's a little bit of a mess, I've saved exercise files on that drive. I strongly recommend when you are working with the programs that we're using to learn logic that you save your files somewhere that's easy to locate. Also, ideally, you'll make a backup, right? So sometimes people will just email stuff to themselves. Okay, so you'll notice that you've got the installer files, and then once you've installed the thing, everything that you need is in the LPL software folder. You and I are going to talk first about Tarski's World. That's the first program we've already started to use. And if I'm not mistaken, most of the initial homework that we're doing is completed using the Tarski's World program. But we'll also use Fitch a little bit today. And we're going to be using these in connection with understanding the concepts that we've been working on and will work on. And then lastly, we'll talk about using the Submit program. Submit is not a program on which you learn logic. Submit is an email program, effectively, right? So if you use a web browser-based email, or you use, like on my Apple products, I use Mail. It's like that, right? You can attach files and send them. It's just a one-to-one between you and this grading system called the GradeGrinder. Okay, well, we'll get into that. First, let's go back into, I'm in the wrong place. First, let's go back into Tarski's World. And two things. One is, I do apologize that we're not in a room where we're all sitting at computers, because I know for a lot of you, watching me do this stuff is not as good for you as you doing it yourself. Sadly, we don't have a computer lab for our department, but maybe one day. You'll notice that there are two versions of Tarski's World. we've been using Tarski's World 6. I will show you Tarski's World 5, if for no other reason than because I mentioned to you, I think sometime earlier this week or maybe last week, that the older version I actually prefer in terms of its layout. So here, whoa, hey, ho. So here, you've got the world on top of the sentence pane. In the other version, let's see if it opens up here, it should. In the other version, the world, although it's not as visually complicated or attractive as the more recent version, the world is on top of the sentence pane, and I like that. It's just easier to see. But people tend to still, nevertheless, prefer Tarski's World, the newer version. Okay, so I'm going to operate under the assumption that you remember what we talked about and you're comfortable thinking about the, sorry, let me restate things. You remember that we talked about atomic or simple sentences and you're comfortable with what they look like in logical notation, right? So does everybody remember that an atomic or simple sentence is the most basic linguistic unit in logic? Another way to put it, and this will become clear when we get to chapter 3, but an atomic or simple sentence is a sentence that does not have a connective. There are 3 fundamental connectives that we'll learn in chapter 3, and then 2 more are built out of them that we'll get to in chapter 7. Okay, so if we understand that, yay. Next question is, do you remember how we write an atomic sentence in our new language? And if so, tell me, based on what we were talking about on Tuesday, what I should write for sentence number 1. Do you remember what we had on this program? I think it was on the program, not on the board. Does that seem right? Miguel's nodding, so yay, okay. I always look for at least one nod. Do you remember what we had in sentence number 1? I want to say it was something like larger
CF.
Yeah, so let's do. So how about this? We'll do the same thing, but let's use slightly different names. So let's say larger AB and PS. I'm going to go up to the sentence drop down and make the font larger, right? So we have capital letter L for larger. So the predicate, the first letter of the predicate is capitalized. And then the names, or name, if it's a single place predicate, go in parentheses, right? So when you have a multi-place predicate, you've got the what is typically the grammatical subject, right, goes first. But both logical subjects, the individual constants, go in parentheses lowercase, right? So how do we read the sentence? A is larger than B, right? So we go from the left to the right, or right to left, sorry, right to left, and then back again to the right. All right, now, what version of truth do we have here in Tarski's world? Well, most directly we have, if you will, a correspondence theory of truth. That is, that there has to be a world that does or does not correspond to the sentence or vice versa. So we'll oftentimes talk about sentences as truth bearers insofar as the sentence does or does not correspond to a world. So tell me what world to build to make this sentence true. Do I have to use a tetrahedron? Nope. Do I have to use a dodecahedron? Do I have to use a cube? No. This sentence is not about shape, it's about size. Okay. More specifically, the relational predicate, so we've got these two things, A and B, and we're not told what shape they are, right? But we know that there is a relation between A and B, namely that A is larger. Tell me what to put. You've got a number of options. Connor, what do you want?
Make a real tiny cube.
Okay, so now let's use some technical language. A real tiny cube in Tarski's world is going to be small, medium, or large?
Small.
Small, good. And you said which one you want, A?
Yeah.
Okay. Do you guys also remember that? And this is going to be an interesting feature for us to pursue a bit later. You can name rephrase. You can use multiple names for a single object, but no two objects can share a name. We need to make sure that we're very specific about our names because we don't want to mistake, let's say, one Harrison for another, right? So only one object gets the name Harrison. Can't do that in this system, though, unfortunately, because our letters stop at F. That's okay. So A is larger than B. What do we need to do in order to make the sentence true?
Make B medium true.
Well, let's hold on. Let's take what Miguel is saying and push on this a little bit. I'm going to hit the verify button, and I get the plus mark. Now, if a sentence is true, you get a capital T to the left of the number. It's in green. If the sentence is false, you get a capital F in red, again, to the left of the number. But here we're getting a plus mark. Now, here's something interesting about this correspondence theory. And by the way, for you scientists, this might be interesting to think about. In order to evaluate a sentence's truth value, that is, in order to determine if a sentence is true or false, a world has to obtain with those elements in it. Right now, what's missing from this world? B. So we don't know if the sentence is true because B doesn't appear for us to evaluate. Sort of right now, the sentence can't be evaluated full stop. So we need, and so this is why I pause. Miguel made this really important point, but he's already created a world that's not yet there. So what do we need to create in order to make this sentence true?
Smaller B or larger.
Okay, so we need to create another object, right? Because an object won't be larger than itself. So the object that's named A can't also be named B. So we'll name this guy B. Right now, the sentence is false. So what do you want me to do?
Make A larger.
You want to make A larger, okay. Oops, come here, you. Make it medium?
Sure.
Okay, so right now the sentence is true. Okay, next sentence, and I want to say Kyle or Connor, I don't remember who mentioned this. You were operating off of what we were doing on Tuesday. What was the next sentence like? It was another larger than. I think we ended up with 3 objects, sure. Yeah. So should we say, let me try this, because there's a direction that we want to go. And because I don't remember exactly where we left off on Tuesday. I'm going to say that A is larger than C. Okay. Now, Miguel says we want 3 objects. Sure. Let's go ahead then and make C what?
Dodeck.
Okay, we can make it a dodeck, sure. What size do we want to make it?
Smaller.
Okay, so it's small. So verify both sentences are true, yay. Now, let me try to pull this screen down a little bit. Okay, Control A for after, Command A for after, add a sentence after, Control or Command A, depending on whether you're using a Windows-based or an Apple-based. You can also go up to the sentence drop-down menu and use the drop-down to add a sentence after. I am going to make another sentence A is repeated, so if A is larger than B, A is larger than C, I'm going to go ahead and infer that B is larger than C. And I'm going to click verify all, and it's false. Why is it false? Because in this case, B and C are the same size. I could make the sentence true, right? In other words, I could go ahead and make B medium, and I'll make A large, right? So I could make a world in which all three sentences are true. I can also make a world in which the first two sentences are true and the third is false. Okay? Hold on. Don't let go of that idea. Right? So keep that in mind. And what I'm going to do now is change the elements. Can everybody see what I've written? So sentence 1, A is larger than B. Sentence 2, B is larger than C. Sentence 3, A is larger than C. Okay. So, question for you. If it's true that A is larger than B, and if it's true that B is larger than C, must A be larger than C? Or can I make that sentence false like I did with the last example? With the first example, I should say. So let's start with this. Okay, so I've made B medium. I'm going to hit verify all. Okay, now let's bring you back to the other example, which I'm actually going to write on the board. So we had a world, so sentence 1, in which A was larger than B. Sentence 2, A is larger than C. And then I'm going to call it the inference, even though there's no explicit notation for us to see that 3 is an inference in Tarski's world. The inference was that B is larger than C. Right? Now, isn't it true that we were able to build a world in which sentence 1 and sentence 2 were true, but sentence 3 is false? Yes? All right. And again, what did that world look like? Here's A. Here's B and C. And don't let the fact that my, artistic skills leave much to be desired. Is it fair to say that A is larger than B, A is larger than C, and it's not the case, however, that B is larger than C? Yes? Okay. So we had true, true, false. Now come back to Tarski's world on the screen. Can you do for line 3 here on the screen what we did just a moment ago on Tarski's world and that I duplicated here on the board? Can you maintain the truth of 1 and 2 while you falsify 3? Kevin's shaking his head no. Miguel's shaking his head no. Boot, what are you thinking?
So this is, I might be getting my vocabulary wrong. This is kind of like a symbolic argument where like the conclusion could be possibly true based on the premises, but not necessarily absolutely true.
Wonderful. Okay, so I'm going to just bracket off the notion of synthesis right now. we won't get into that terminology. What Rayut's saying is this: lines 1 and 2 on the board, right? A is larger than B, A is larger than C, do not by themselves force you to accept B is larger than C. As Rayut says, line 3 could be true, it could be false, right? In fact, we made it true in one instance, and we made it false in another instance. So, this is a really important point. When a sentence can be falsified, more specifically, when a conclusion can be falsified without making the premises false, so the premises stay true, the conclusion is false, we would say that that argument fails. It's not logically correct. The technical definition is it's an invalid argument. Language that we use, the language that we use in this class also includes the following. The third sentence in this case is not a logical consequence. On the other hand, go back to the screen, when it's impossible, and that word is really important, impossible. When it's impossible for the conclusion to be false, when the premises are true, if the premises are true, that argument is valid. That sentence is a logical consequence. Okay, so let's write this stuff down. You're going to find that this most crucial concept in logic is either super intuitive and it clicks right away, but maybe you lose it and then you get it back, or it clicks right away and you never lose it. And for some of you, when you lose it because when you start to talk about invalidity, then things get confusing. And for some of you, it's confusing from the beginning. Don't worry. I think I've said this before. One, if Mia can do it,
We can do it.
right. Also, yeah, confusion, like puberty, sucks, but it's normal and natural. It's okay. All right, so here we go. An argument is valid when it is impossible for the conclusion to be false if the premises, which I'm abbreviating here as PRR, if the premises are true. Right? We tried to falsify the sentence, A is larger than C. You probably did it mentally, but you couldn't. We can even try to falsify it in Tarski's world. Okay, so I'm going to make B large, right? Or sorry, no, I shouldn't do that. That won't help with that. Let's try to falsify the conclusion. Let's make C large, right? Notice, okay, I falsified the conclusion, but now sentence 2 is false. Okay, I shouldn't make B as medium be smaller than C, B has to be larger than C. Okay, I'll make C be medium. Okay, great, but oh shoot, now I've made the conclusion true. It doesn't matter how you mess about with the world. If you want to maintain 1 and 2 as true, you can't falsify. It's impossible. So this is a hugely important concept for us. And argument is valid because in every possible world, there are a lot of possible worlds in Tarski's world. But it doesn't matter what world you build, in no possible world will you have A, B larger than C come out false. Or in other words, you will never be able to falsify A is larger than C if it's true that A is larger than B and B is larger than C. Okay, So this notion of possible worlds is going to be really helpful to us, I hope, in thinking about the concept of validity. So going back to Rayut's point, just because in the other example, A is larger than B, A is larger than C, you could make the sentence B is larger than C true. Just because you could make it true doesn't mean that the inference is a valid one, doesn't mean that sentence 3 is a logical consequence of 1 and 2. That's because what matters is that you can falsify it. Okay, now you might feel like you're playing a little bit of mental twister, but it'll get easier as we go forward. Is it Miguel or somebody had a question or a comment? What are you thinking?
I know this is important, but I kind of wanted to point out that the only reason we can't falsify it is because Tarski's rule is limited to 3 sizes. So if we were doing it like on the table, we could definitely make that
So are you saying that if we had more concepts to deal with, we could make sentence 3 false?
I'm saying we can make all of those true if we had one more size.
But, well, okay, so I'm sorry, I'm thrown off a little bit. Are you comfortable, though, with the idea that the creating a world in which they're all true is not what makes the inference valid, is not what makes the third sentence a logical consequence of the first 2? Oh, yeah, okay, all right, good. And let's push on this idea a little bit more by now introducing the notion of analytic consequence. We're going to find, and this will become clearer as we go forward, particularly when we're in chapter 4, that there are different ways in which we can talk about validity. The scope of the concept can be narrowed a bit. For right now, when we're talking about a valid argument, we're talking about any argument, right, whose conclusion can't be falsified if the premises are true. We'll see that there is another way to think about validity, which is a little bit narrower. Okay, so if that doesn't make sense right now, don't stress over it. I'm just sort of saying, file this away. This is going to come up later. For right now, let me try this, because we're going to use analytic consequence. When we just look at the meanings of the terms and we pull an inference from those meanings, right, and that inference is impossible to deny, so the conclusion can't be false, we have a sentence that is called an analytic consequence of its premises. So let me try and make this a little bit clearer. An analytic consequence is a valid, rephrase. An inference whose correctness, that is, whose validity depends entirely, or no, let me cross that out, depends on the meanings of the terms. Okay. So I'm about to give you an example of a non-Tarski's world valid argument, aka analytical consequence. Right? What are you thinking of? Hold on just one second. Thanks.
So to my understanding, validity relies on correspondence theory, and so does analytical consequence rely more on coherence to the reality of the
So strictly speaking, validity is not restricted by this or that theory of truth. That's the short answer. Is that, yeah?
But so like if a sentence, not a sentence, like an inference is
Well, it'll be reliant on, let's say, stipulated meanings or objective meanings that are, let's say, agreed upon. And I'll try and give you an example of.
So like meaning as use, basically.
Could be, yeah, meaning as use. Yep. So example here, you guys understand the meaning of the relation larger. So just from the meaning of the relation larger, you're able to draw the inference. You don't actually need a world, right, for it to bear out. All you have to do is think about those meanings, right? If you're thinking about the happy cows argument, right? Great cheese comes from happy cows come from California. Therefore, great cheese comes from California. You understand the meanings of the terms insofar as you know that we mean the same thing by happy cows in each iteration. We mean the same thing by great cheese California in each iteration, right? But it's really the relation of the terms, right? The structure of where they appear, right? As well as the implied quantity, right? All great cheese is cheese that comes from happy cows. All happy cows are cows that come from California. Therefore, all, right? So it's that combo relation. Example, this is both a valid argument and the conclusion is an analytic consequence of the premises. Just like larger, how about this? Lola is older than Ralph. Ralph is older than Camille. What follows from that? Lola is older than Jamil. So I don't know Lola, I don't know Ralph, I don't know Jamil, but I understand the relation older, right? So that I draw the conclusion just by the meanings of the terms. Now let me go back to a point that Rayut made and offer the following example. If I say, I don't know, Mia loves Nathan, Nathan loves Todd, therefore Mia loves Todd, do you think that the conclusion Mia loves Todd is a necessarily true claim just based on the premises and Miguel saying no? And not Evelyn, you're Evelyn. Elizabeth, you're Evelyn. It's the E part that threw me. Okay, so Miguel shaking his head no. Miguel, can you talk a bit about why you think that the loves inference is not valid?
Kind of difficult to explain, but older is like a relationship between things, but love is an emotion afterwards. I can't.
Okay,
explain it
so love can sort of, love can ebb and flow. Emotions are maybe, we don't know how they're felt from one person to another. We sort of, crab walk our emotions so that we say, oh, I understand love, the love you're talking about, even though I don't know what you're feeling, right? Okay, so older is, has a meaning that we can capture by some sort of unit of measurement. It's really hard to quantify love. More precisely, although I think this is part of the track that you're on, love is not a transitive concept, right? In other words, I can't transfer the love that is felt from one person to the next, right, over to a third in the way that we can transfer the unit of measurement older than or larger or next to, something like that, right? Okay, so this inference is a valid inference. It's also what's known as an analytical consequence. Now, why am I making a big stink about analytical consequence? Because we're going to use ANACON, the abbreviation, as a justification for making an inference when we move into the Fitch program. So that's about where we're headed. Are you comfortable first with the concept of an argument? Do you feel like if you're asked to work with that concept, you can identify a premise, you can identify a conclusion? What do we think? So far, so good? Okay. Now, if you're confused, remember about the concept of validity, don't worry, it does become familiar. You do get used to it. One of the things that I found with this stuff is that, you know, when it does click, it's like everything suddenly makes sense, right? It may not open up right away, but it will. All right, so what is the key feature here for an inference? Do we care about whether or not we can make a world in which, in this case, all three sentences are true? Another way to put it is this: when we test a piece of reasoning for validity, or when we test to see whether or not a sentence is a logical consequence of another or others, do we care about whether the sentence is true? No, we care about, and this is the part that can be confusing, we care about whether or not we can falsify that sentence. If you can falsify a conclusion without violating the truth of the premises, the argument fails. It's invalid. Okay? For some of you, you're like, yeah, okay, all right. And for some of you, you're like, but we'll get there. I'd like to leave this guy up, this Tarski's World up, and what I'm going to do is open up our Fitch program. Now, one of the things that is really terrific about each of these programs, but I'm going to highlight it on Fitch, or in Fitch, is that as you're working, you basically get immediate feedback, right? So in my day, when I was doing logic, I did everything by pencil and paper, and you know, I couldn't check my work as I went because, you know, the answers weren't in the book, and I maybe didn't have access to my instructor, right? Here, you can check your work as you go. You get some feedback. You can either confirm that you're correct, or if you're not correct, you will get told, right? So just like in Fitch, or sorry, just like in Tarski's World, when we made a sentence that couldn't be evaluated, we got a little plus sign, right? So you get some feedback. All right, so let me show you what you're looking at. Let me first make the font size as large as possible and darken proof lines. Okay, so what you're seeing, you can see the cursor flashing, right? What you're seeing is the start of what will eventually be a proof. Go back to your geometry days, or go back to, you know, long division or some long math calculation, right? I'm not saying you have to love math or that you have to have loved specifically geometry. I'm just talking about format, right? So you already know that we lay out an argument as follows. In an argument, we put our premises one on top of the other, and then there's an inference after, right? We also know that in a math derivation, you have you have intermediate inferences, and then you get to the end. The layout's the same. Okay. All right. So let's take what we had in Tarski's World. So A is larger than B. Now what I'm going to do is add a premise. I can do that by either Control or Command R, or you go up to proof, add premise after, or you could do add premise before. I think but you'd have to move your slider around. So what's the slider? I don't know if you guys can see this, but to the left of the numbers and the vertical line, there's what's called a slider, and wherever you want your cursor to go, your slider needs to go. Okay? All right, so A is larger than B is larger than C. Now, you may not see this, but so I'm going to tell you. Immediately below line 2, there's a teeny tiny little hook or bar. It is perpendicular to the vertical line. It's a horizontal. That's called the Fitch bar in the Fitch program. It's the Fitch program's way, or the Fitch format way, of showing you this line that demarcates the separation between premises and conclusion. So I'm now going to use Control or Command A, and notice that line 3 appears below the Fitch bar. And I've got my inference, A is larger than C. Now, to the right of line 3, do you see and I apologize that I can't make I can make the font larger, but I can't make anything else larger. There's no scaling, unfortunately. But so to the right of line 3, do you see there's the word rule and a question mark? And then to the left of the word rule, there's a little upside down triangle. That's a drop down menu. Now, when we draw an inference in logic, we do two things. We cite the source or sources of the inference. Where'd you get it is the question that we must answer. And we justify. What rule justifies this inference? Okay. So with my cursor at line 3, I'm going to click line 1 and 2, and the numbers show up to the right. So my sources are cited. I derived line 3 from lines 1 and 2. And right now, we don't have a formal rule name. We just have, well, it's a valid inference, right? We don't have a technical name beyond that the inference is valid. We know, that, however, that the inference is an analytical consequence, right? And in fact, we will use Anacon not just for specifically the analytical consequence of a premise or premises, but as the catch-all mechanism that says, hey, the inference is valid. So it doesn't matter what sort of validity we're talking about, the more narrow type that we'll get to, for example, in Chapter 4, which is a truth functional concept of validity. We will use Anacon as our catch-all. Any valid inference, we're going to say, is an Anacon inference. And that also makes sense because at the end of the day, there is an important sense in which just from the analysis of our premises, we're yielding the conclusion. Deductive logic is a non-empirical logic. It is a process of analyzing and employing the relevant rules, as opposed to some sort of, let's say, empirical observation or empirical analysis. So we say Anacon, and now here's feedback, check the step. Yay, we're correct. Okay. Now, let me offer you this. Suppose that you've got a pretty complicated looking argument, and unlike this argument, it's not at all obvious to you that the thing is valid. You want to test it for validity. Well, that check mark is the result of an algorithm that's running in the background. This will make more sense as we go forward, so that if you have an inference that you're not sure about, you can type in if it's a pre-given argument, you just put the conclusion in the immediate inference, in the next line immediately after the last premise, or you can type it in, and then you click Anacon and say, hey, is this valid? So let me give you an example. the one we just had on the board, we said A is larger than B, A is larger than C, and then B is larger than C. Now I've already cited and used the drop-down menu for Anacon, check the stat. X. The red X tells you that the argument is not valid. The red X tells you that the inference is not an analytical consequence, or the conclusion is not an analytical consequence of the premises. Okay. For our purposes right now, you want to grasp the concept of validity, and you want to start practicing with testing an argument for validity. That's what we want to run away from here today thinking about. Sophia, what are you thinking? I don't follow. I followed the first part, but then I didn't understand the second part. Are you supposed to put the premises what?
Like it says Anacon had one comma.
Oh yes, Yeah, so you always need to cite your sources. Otherwise, the program doesn't know what you're trying to justify exactly. Does that make sense?
It's always the premises that go there.
Yes. Oh, I see what. I think I see what you. Yes. Okay. Now, we are going to get formal rules, and we'll talk about those in some detail, in a lot of detail actually, on Tuesday. For right now, let me simply say that you've already worked with the rule that we learn in Chapter 2. Do you guys remember that we did something like this? So, if I say A is identical to B, all right, so let me do this just to not let us get distracted by the world. If I say A is identical to B, B is larger than C, so A is larger than C, do you guys remember how you work with that identity symbol? Does that make sense to say? In other words, can you see intellectually that 1 and 2 yield 3? This is a couple people nodding. How can we, let's do this. How can we articulate lines 1 and 2? In other words, tell me what world to draw. What do you think? Look, Sophia, what are you thinking?
Just like tell you what to.
Uh-huh.
Okay, so let's make A and B whatever shape or medium.
Okay, so you don't care about the shape, but you want A and B, or you want the shape to be medium, and you want me to do what next?
Both A and B medium, and then C like small.
So you say both A and B medium. Are we talking about one object or two?
Oh, like two different ones, A and one's B.
Okay, good. I'm glad you said that. Oops. Question for you guys, and I hope you don't feel like I'm picking on you, because I'm not. I'm so thrilled that you have said what you think. In fact, it's so important for you to say what you think, because if you make an error, that will become very clear very soon. Or if you haven't made an error, you'll be confirmed in what you have articulated. And I'm not a cognitive psychologist, so I don't know what it is about saying what you think that somehow oftentimes makes being corrected a self-correction, or being confirmed a self-confirmation. But I think you're going to see in just a moment, Sophia, that if line 1 is true, we can't have this. So I know a couple of you are chomping at the bit. I want to ask you if this is what you're thinking. when you think of identical with, are you thinking of, oh, it's the same size, same shape? Kind of like, we talked about this with names, remember? There are lots of Mias in the world. I know it seems like I'm the only one, but there are lots of Mias in the world. But only one is identical with me. So if there's another Mia, that's not me. Yeah? Okay. So just because B and A are medium cubes, does that mean that they're identical? No, they're very much alike. So what do we want to, does that make sense? Yeah? So what do we want to do? Tell me what to do. What do we want to do to reflect A and B's identity? What do you think?
Get rid of.
Well, right now they are the same color, shape, and size, but check this out, guys. What? False. What? Do you guys still do that? What? No, I don't know. Nobody tells me anything. What's the problem here? Come on, you know you want to say it, Connor. What are you thinking?
You gotta get rid of B and then name one of the cubes A, B.
Okay. Ha-ha. Okay, so when we have the identity, so Sophia, thank you, because this is hugely important for us to understand. And I would say 9 out of 10 of us typically think identity means like duplicated. No. It's one and the same as. Okay, we're all right with that? All right, so if A is identical to B and B is larger than C, what do we need to write to make B larger than C? We need to, thank you. We need to, first off, name an object C, and we need to make sure that it is smaller, right? Okay, so verify, we're good. Verify, we're good. Now, question for you. Can I falsify the conclusion without messing with the premises? No, I can't. And if you're not sure and you want to try, go for it. Also, guess what else you could do? So let me put this over here. Okay, let me move. Oops, let me push this over here just a little bit. All right, so we took sentence number 1 and we made A identical to B. Now remember, the question is, can we falsify line 3? You guys said no. Another way to ask the question is this: is 3 an analytic consequence of 1 and 2? We get the check mark. Yes, it checks out. Okay? So, let me offer you now a more precise articulation of the inference. And again, we'll talk about this in more detail, but there are a couple of other things we need to get to before we're done today. I'm in the drop-down menu. I click on elim, and you see all these cuckoo signs. Don't worry about those. Do you see the identity symbol? There it is. Okay. The inference can be justified more specifically than Anacon. The rule is called identity elimination. Now let me just throw this out there. This is something we're going to work on later, but we do work on it a little bit now in the way that I've just articulated, and so we want to talk about it, continue talking about it, right? Talk about it now and continue on Tuesday. We're going to be given rules that are symmetrical. we're going to be given rules that allow us to introduce or eliminate, right? So in this case, we've eliminated the identity symbol. That's what justifies the inference. So lines 1 and 2 by identity elimination give us 3. Again, as we go forward, we'll be given pairs of rules. Always intra-elim, intra-elim, intra-elim. Now, you'll find that we rarely, if ever, use identity introduction. And we will talk about why that is, but just know that we're still given identity introduction as a rule, if for no other reason than for the symmetry that we'll have across all the rules that we get. We always will justify in terms of an introduction or an elimination rule. Okay, that's when we're being more exacting. The generic, the most generic justification is just anacon. It's about it. The inference is valid. Okay. So that said, I think you're in good shape to start working on submit. So here's what we're doing, just to finish up. I apologize that if I'm not mistaken, I can't make this window bigger. So the best I can do is tell you what you're looking at. Remember, submit is effectively an email program. You do work, please, and we'll talk more about this on Tuesday, but as you're starting, and you should get started, don't wait until Tuesday night to do all your work, or don't wait till Wednesday to do all your work. Start working on it early so that you can become familiar with the skills and concepts. You're going to save your files as instructed by the textbook. I mentioned already, save them in a place that's easy to access. You know and I know that what you're effectively buying at the end of the day is your registration ID, right? One of the lovely things I think about this suite of programs is that unlike other licenses, your registration never runs out, right? Until you die, maybe the program blows up, the world ends. It's not like, my Spanish lab where you get the license for a semester. This is yours to keep. So key it to an email that you're going to take with you wherever you go. You type that number in. I can never remember mine. It's, mine's L12 and then dash. Yours will probably be L12 and then dash something. So I'm just going to make something up. You'd think I'd remember and I don't. Please use a name that I'll know is you, because this is not synced up with Canvas. It's not like your work goes into Canvas. It's separate. I will look at your work and then I input a score in Canvas. So you put your name in, use an email address that you want to keep. Don't forget, not only am I recording, oh no, that's not what I'm doing, Pierce College. Don't forget, I will post an instruction sheet, and then I'm recording this right now. I hope it's recording anyway. So you'll have this recording, and then there's also a submit tutorial. The instructor's name is Mia Wood. The email woodmc@piercecollege.edu, which I think I'm misspelling because I can't see what I'm doing. Right? When you submit, ultimately, to get a score, you'll include me in the report recipients, which I'll show you in just a moment, and then that will populate Rephrase, and then your work will be populated in our course. Choose files to submit. That's what this lower left button says. Submit somewhere that is easy to, remember, save somewhere that's easy for you to find. I'm just going to grab sentences. Notice the file extension, .sen, .prf. I don't have a .world up here, I don't think, but those .send, .wld, .prf, those are the file extensions that tell you what file type you're submitting. And GradeGrinder needs to know that. So you add what you want. I encourage you to add clusters, right? So when you're ready to submit for me to receive the report, try to cluster bunch all of your files into one submission. Click done. Then over here on the lower right, there is a submit files button. And this is where you see send grade report to just me or instructor 2. So when you are ready, you can submit as many times as you want until everything is perfect, right? I hope when I open up the OpenProof site, the GradeGrinder site, and I look at your work, green check mark, green check mark, green check mark, right? That's what I want to see. So submit as many times as you like. When you are ready for me to be alerted that you're done, you'll hit add instructor 2. You can always send a nice note, add a text message that says, this is the best class ever. Or maybe more helpfully, it will be something like, this was really hard, I struggled with this, this, and this, and then we can talk about it. But you don't have to send a text message. Then you click OK, and then you hit submit. And the cool thing is, you get a grade report back typically within like 2 seconds, no joke. It's much faster than I could ever offer you, right? So you basically get 2 levels of immediate feedback. You get the program level feedback, and you get the level of the GradeGrinder, okay? Now, if you have any questions, problems, confusions, let me know, particularly about the programs we just talked about, but also buying the thing. I heard from a class member earlier, PS, that I was wrong. You can get new, because you need that registration number, and you only get a registration number with a new package. You can get for like $35 paper from Chegg, but make sure it's new.